Alright, so this is going to be part 2 of the radio waves lab, and we're going to test the same radio stations that I tested earlier this morning again now, and it's 8 o'clock p.m., and I'm still in the same location, and we'll still be testing the same radio stations, so the locations and distance away and types of stations will still apply, but we'll test the effects on their clarity. So the first one we have to test is 88.1 FM. So it's coming in again, but it sounds slightly more static than I remember it being this morning. The next one is going to be 90.5. And this one was mildly static this morning, and it appears to be about the same way. It's coming in where I can hear it, but it's not too clear. And the next one's 96.1. And this one's still coming in nice and clear and easy to hear, so that's good. It sounds a little even clearer than this morning. And now 105.7. This one's coming in cleared in as well, so the FM stations seem to be coming in pretty clear, this just like they were this morning. And the next one's going to be 107.1. And it sounds nice and clear as well. So then now we're going to switch over to AM radio, and we're going to start with our first one, which is 750. And it's very static, just like it was this morning, as I recall. The next one is 920. And this one is coming in a little better than it was this morning, and I can actually hear what they're saying, so that's an improvement. The next one is 1510 AM. And I don't hear much of it at all. It's very staticky. And then we have 1590, which is the best of the AM stations so far. I can hear what they're saying on this radio station, and it is staticky, but not as bad as some of the other ones, and not as bad as it was this morning. And then the final one is 1600. And this one seems to be coming in relatively clear as well. So that shows an improvement for the AM radio stations. And to tie up some loose ends here, the process by which radio waves are transmitted from the towers to my radio here, they do have the lowest frequency and the longest wavelength. And the radio stations, each of these that I've tested are each coming from a radio station, and each of those are, they broadcast at a set frequency, and the radio waves are the carrier for the sound, and then the sound waves are converted into electrical signals, and change the carrier waves, and that results in my antenna attached to my radio receiving the electrons, and they vibrate sympathetically at a set frequency, and so that's what makes me connect to a certain radio station and be able to hear it. So then there are different type of factors that can affect the clarity of your radio waves. And so there's things such as weather. And so all waves travel better in colder weather because there's a lower humidity, which means there's less moisture in the air, and therefore there's less resistance provided to the radio waves as they travel through the air. And this change is definitely more noticeable in AM waves than FM waves. However, it does affect them both, and that's because the AM waves have a lower frequency, or the, sorry, opposite. The FM waves have a lower frequency. And so then solar flares and different changes in the ionization of the atmosphere can also affect how well the radio waves are coming in. And then distance is another factor, as we saw with many of the stations we tested today. Some of the ones that were farther away, such as located in Nashville, Tennessee, or Swainsboro, Georgia, didn't come in nearly as well as the ones that were located closest to me in Atlanta. And that's because the farther the wave has to travel, the more chances there are for it to be disrupted or distorted. And this happens a lot in cities, which pose electrical interference problems, and they often have more batch scatter, which causes the waves to be disrupted rather than country areas. So if you were to live somewhere where there's farmland and listen to the radio, you'd probably be able to hear it a bit better than if you were in a city like New York City. In the instance that you went under a tunnel, the signal typically fades However, you see that happen more dramatically with AM waves because of their higher frequencies and their lower wavelengths. And so then also the AM radio stations are often clearer later in the day because as the waves tend more easily travel and be reflected off of the ionosphere than they can during the day, because during the day they usually travel more along the ground. And when it's later in the day after sunset, they can travel through the air better, which allows for them to reach the antenna better. And so we did see that during the morning, the AM stations didn't come in nearly as well as they did at night. However, the FM stations came in pretty clear all day long. So that's definitely an advantage of the FM stations, is that they aren't really affected as many factors, but the AM stations are affected by more of the factors, and they're affected more drastically by the factors. And that's all for this radio lab. So we basically just learned that the radio waves go through a process to be transformed into different types of waves, and then they have to create a sympathetic frequency with my radio in order to be transmitted to me. And based on if it's FM or AM signals, they will be affected by different factors, and that will affect the clarity of your radio.